and welcome to my presentation on spectroscopy in brewery engineering. My name is Karla Caro, and I am going to be talking about this topic. Just a bit of background information. What is brewery engineering? Brewery engineering is the technical work that is involved in the design, construction, and operation of a brewery, including process equipment and production plant. As engineers in brewery, it works all on all of the elements of the system. And the steps in a brew include malting, mashing, watering, boiling, fermentation, packing, and carbonation. On the picture on the right, you can see that these are all fermentation tanks. These are all basically brewing tanks that are in a brewery, and each tank has a specific job and a specific step in brewery. So it goes from like one system to the next. And usually it starts with grains. They're like seed-like looking grains that starts as a brew, becomes a malt, and then mixing it all up, adding some stuff, and then it becomes a brew. But those steps are further on in this presentation. So, like I mentioned, steps in a brew include malting. So it means that the starch or the grains, or like barley, and it gets soaked in water to germinate. So this process takes maybe like about an hour or so, or possibly more, just to make sure that everything is super soaked and super, I guess, like mushy. So then, once it's getting all mushy, so it doesn't become, it goes from like solid to like kind of like a water like consistency. The next step is to start mashing. So these crushed grains get mixed with hot water to help extract the sugars that are in these malts, that are in these grains. I mean, I don't know if I can show it with my mouse, but let's see. We are starting right here. So this is where the grains get into this tank. It's like a little mill. Once the grains are all like germinated and mashing begins, right? Oh my gosh, right around here on the second part. The mashing crushes these grains with hot water and extracts sugars. After that is lautering, which is just basically the hot water that is sprayed on the mash. It helps rinse out the sugars. So it puts it in another tank. Then boiling, before that, this mixture that started out as grains mixed with hot water, getting out of the sugars, it becomes to wort. This wort, WORT, is then boiled to sterilize and stop enzyme activity. After that, hops are added. So these hops is basically like the beer part of it. Although it is very dangerous to like other living organisms such as like possibly dogs, it's like a very big issue. So yeah, adding hops very carefully. It's not poisonous to us. It's not poisonous to humans, but it is very dangerous for like other creatures. So yeah, adding the hops makes it bubble and it makes it become more of like a beer-like structure, but it's not beer yet. After that, everything is put into fermentation tanks, which are then fermented. And fermentation takes a long time. This whole like brewing process takes like at most like maybe like a couple weeks to 3 months. It just depends. It depends on if you want like a more harsher tone of flavor or a lighter tone in flavor, or it's even like the flavor in general that takes these times. We can get on that later. So yeah, fermentation is when you add yeast, and then that yeast helps consume the sugar in the wort and produces alcohol and carbon dioxide, which then becomes beer. So that fermentation needs to be closed and needs to be put in a well constructed area, and it needs to be placed in a consistent like temperature, that sort. After fermentation, once it becomes beer, um, then packing the beer, basically putting it in bottles and cans, whatever of the sort. I usually do bottles. And then after that, carbonation can be done naturally, or you can add CO2 under pressure. When I make beer, it's usually at home, and the carbonation happens on its own. So applications in spectroscopy, brewery involves I'm butchering that name. Brewery involves spectroscopy for each brewing stage. So each of the stages that I just mentioned before, spectroscopy is very important to make sure that everything is up to date, up to par, making sure everything is to the T, essentially. So according to the articles that I just found online, it states that near infrared or mid infrared spectroscopy offers opportunities to predict dozens to hundreds of compounds at different stages of brewing processes. NIR spectroscopy can measure out the percentages of moisture, starch, and protein in the grains and other raw materials before brewing starts. So if you want a more consistent flow of your brew to make sure it's basically as perfect as you can make it, NIR spectroscopy can definitely help with that. Both NIR and MIR spectroscopy can also be used to successfully discriminate between hop varieties. So if you don't want a bitter brew or you want a very bitter brew, then that can help measure out the bitterness of the hops that are added to make the beer. NIR spectroscopy and beer fermentation. Another journal mentioned that the NIR spectroscopy has been proven to be effective for quality control in malt, which is like that mixture when you mix the hot water and the grains, and hop analysis. So it helps monitor the mashing process and analysis of fermentation samples. Since the 1970s, quality testing determines the important functional components like protein and moisture content of barley. So this is basically where it all started. Successful correlations have been used to determine percentages in alcohol and nitrogen, and analysis and fermentation processes to help real-time processes and maintain control subsequent batches. So this spectroscopy like really ensures like quality control and makes sure that everything is to the T, as perfect as your first batch essentially. So obviously in like a power, it's like kind of like a power plant where you need to make consistent product. That's basically what spectroscopy can be used for in this sense. Examples of findings here just indicate that like the more concentration that you have, the more correlation you get. So in this case, nitrogen is found and it's correlated well. The specific gravity is found and it's correlated well. So like for consistent spectroscopy, correlation is found. So this correlation indicates that everything is precise and accurate. So the motivation of these articles that I found, they just wanted to indicate the importance of maintenance and real-time monitoring in chemistry processes, which is the brew itself. And it also ensures that the starch for more rapid and efficient methods can lead to the development of applications in near infrared spectroscopy. In this feed forward strategy, it helps demonstrate how brewers can utilize the spectroscopy for quality assurance through early detection and efficient fermentation processes or performances. Why did this topic interest me? In short, I took a class in brewery engineering this previous semester. Our final project of the class was to make a beer from scratch and at home to present it to the class and have a taste test. I brewed a coffee porter and I got a perfect A in the project. And my beer was the best of the class. It had the right carbonation. It had the right coffee flavor. It had a burnt malt, which was perfect actually because it tasted like I know it sounds wrong to say that it tastes like burnt coffee, but it really helped bring the coffee flavor out. And yeah, it was just a very fun process. It was an at-home process. I had a large pot of just making beer, and this process took about maybe like 2-3 hours of preparation, about an hour to make the beer, like make the concoction, to put it in a canister and to store it away like somewhere in my house to keep the temperature. In that fermentation process where it was in a canister, it was then how do you say it? It was put into like I think my storage closet and it was like kept at like 65 degrees temperature, and that helped the fermentation process stay consistent and basically like come out like this picture that it shows. So obviously with that, I got to siphon it with like a tube and then put it all into bottles. I made like 50 bottles. So I still have the kit at home. It's an at-home kit. It's really fun to play with and make new beers, and it's honestly like a topic that interests me, and I really want to look into brewery outside of NMSU or like after graduation, all that stuff. But enough of that. Moving on. Yeah, these are my references. I thank you for watching. Thank you very much.